Hello and welcome to this lesson. Now you need to find an optimal solution to the given problem. I want to be straight with you in this video and tell you that you won't magically find an optimal solution if you didn't practice a lot before. I know that finding the solution might not come naturally to you from the beginning. So the first thing when you receive the problem is to make an idea of the data structure that you need to use. After you spot the data structure, think of typical algorithms and problems that you have seen before using this data structure. For example, if you receive a problem with trees, it's clear that you need to use algorithms specific to trees, such as recursion, right? If you receive a problem telling you to find the minimum or the maximum in a sequence, then think of heaps or sorting or stacks. And the list of such example continues. The key here is that practice will tell its word now, and I have good news for you. Many interview questions are similar, so there is a high chance that you practiced a similar problem before the interview and you can build a solution starting from that. The moral here is pretty basic. The more you practice before the interview, the easier it will be to find an optimal solution. There is no such trick or shortcut to solve a problem. If there would be one, everyone would use it. Now, the other thing that is crucial at this step is to talk loud. The interviewer is interested in seeing your thinking process and hearing your explanations. Most people stay quiet for 3 minutes while thinking of a solution. And that is the worst strategy possible for them. Don't be one of them and talk loud. Make the interviewer really understand what you want to say and don't assume he gets bored while hearing you. He is there to listen to your thinking process. Don't be scared that you might start with a bad solution. There is time to improve it. The two things I want to remember from this video is to practice a lot before and talk loud during the interview, period. Now we'll move to finding an optimal solution for the problem explained in the previous lesson, and I want you to pay special attention to how I speak and explain. Think that now you are the interviewer and I am the candidate. I will try to do my best to explain, and if you understand what I'm explaining, it means that I'm doing a great job as a candidate. If something is unclear for you, feel free to let me a comment and be sure that I will read it and take your opinion into account. Now here is the problem that the interviewer gave us, and you as a candidate need to take a bigger example and start thinking of the solution. Now I will start talking from the perspective of a candidate being in a real interview. Now I want to put you in the position of seeing what it's like to be on the other side of the table, the interviewer, so that I would behave like explaining the solution in a real interview and you can make judgments on my explanation. You can be in the position of just listening to my explanation and thinking process and find out if you understand what I'm explaining and what you don't understand, so that you see what you need to tell in the interview and what doesn't make sense for the other person, right? Now I see that I need to find a solution in the least number of steps. And now the first thing I see is that there are cars which are already on their desired position, so we don't need to make any changes to them. Now to the other cars which are not on their desired position, we need to make the least number of changes so that we put them on the right position. Now the easiest move I can do is to put a car on the empty space, which is 0. And this might be a very useful operation when I put the car that is desired on that position on the empty space. So if I put 4 on the empty space, then 4 will arrive on its desired position in just one move. So we see that there is one type of move which requires just one operation. Now if I look further to the other elements, I see that, for example, if I want to put 3 on its position, then I don't see an empty space there. There is one. So I need to move 1 to the empty space so that the empty space come on the position 1. And then I can put 3 on that position. Meaning that there are some cars which require 2 operations, right? So, having these 2 operations, when I see this alignment of 2 arrays one between the other with the same number of elements and the same elements basically, I'm thinking of a permutation because permutations look quite similar. And if I dig a little bit deeper, I remember that in a permutation, cycles played a very important role. And I think that I can do something similar here with cycles. So if, for example, I start from 1, then I go to 3, and then I go to 1 back, then I see that it somehow forms a cycle. Let me make the same thing with the other ones and see if we can spot something. So if I go from 0 to 4, now I go to 4, 2, then if I move further, I see that there is another cycle there. Now moving forward, 5 to 6, and there is another cycle, and 7 is already on its desired position, so we don't take into account. Now, having formed this, let's call them cycles, I can see that there are 2 different types of cycles. So there are these 2 cycles which don't include the empty space, and there is 1 cycle which includes the empty space. Now, there were also 2 types of car moves, the one which require just 1 move and the one which require 2 moves. And the one which requires 1 move, meaning the least possible moves, will of course be found in the cycle which has the empty space. Now I'm focusing my attention on that one. And firstly, I see that I can put 4 in the empty space in just 1 move. And 4 arrived on its desired position, so we don't have to move it further. Now, if I put 2 on the empty space, then also 2 arrive on its desired position, and now the empty space is also on this desired position. So we finished moving all the cars from this cycle to their desired position. Now we still have 2 cycles which we need to solve, and we see that in these 2 cycles, all the cars require 2 moves to arrive on their last position. For example, if I want to put 5 on its position, I need to move 6 firstly, right? Let's make this change so that we move 6 on the empty space. And now we see that the cycle is a little bit bigger. So from 5 we go to 6, then from 6 we go to 0, and actually we made a cycle of the first type, which include an empty space, right? So now we can start moving all the cars using the same approach as we used previously, meaning that we can put 5 on its desired position in just 1 move. And we also can put 6 on its desired position in just 1 move. And this cycle is now formed. The cars 6 and 5 are on their desired position, and also the empty parking slot is on its desired position. And there is one more cycle to which we can use the same approach. So we can move, let's say, 3 on the empty space. And the cycle became now of the first type, which included the empty space, meaning that from 1 I go to 3, then from 3 I go to 0, and this is the cycle. Now I can start making the changes in such a way that I put the car on the empty space, and now I put 3 on the empty space, and now the parking lot looks as we desired to be. Now I want to reason why this approach looks optimal to me, and that is because a car can be put on its optimal position in at least 1 move, because obviously we need to move that car on that position in 1 move, right? So if on that position that we want it to be there is the empty space, we can just move the car on that position on the empty space, and that's it. We used just 1 move. So in the approach I just explained, I use this greedy approach in which I put cars on the empty space until I can't make more changes. And now I'm moving the attention to the cycles which don't have the empty space inside them. And we saw that we need a way to break these cycles and introduce the empty space into them. So I make one move to break a cycle, and then I continue with using the empty space to put cars on their desired position. So basically, we try to maximize the number of one moves which put cars on their desired position. Now, talking about the complexity, the time complexity is ON because a car is moved at most 2 times. Most cars are moved just one time when you put them on the empty position, but when we break the cycle, we make one additional move. So the time complexity is ON, where N is the number of cars in the parking lot. Now, talking about the memory, we need just some basic arrays, so it is ON. And this is how I would explain the solution to this problem in a real interview. Now, if you understand my explanation, it means that I explained it well. If you didn't understand something, it means that also the interviewer wouldn't like my explanation that much, right? So I made this video to put you in the posture of being an interviewer. Now you had the chance to listen to someone who would be the candidate. Now, after you explain the solution and the interviewer also say that it's good, you need to move to the next step, which is coding the solution. Now, we'll code the solution in the next video, and I want to remind you that from this video, you need to remain with 2 things. The first one is that there is no shortcut to finding a good solution. It's just the practice and how much time you devote before the interview to prepare. And the second thing is that always talk loud and explain what you are thinking, because at the end of the day, this is what the interviewer is looking for, to see your way of thinking. So talk loud and explain everything that you are thinking at that moment. Now in the next video, we'll move to code this solution. So see you then.